Okay, so then we'll look at some questions from tutorial sheet 4. I received Math 1100 Foundation Mathematics tutorial sheet 4 of 2021. Let's go straight into our topic of discussion today. So, what are polynomial functions? Basically, polynomials can be defined as a function of degree n, whose the highest power of the independent variable n can be expressed as that. Say that function is f of x. So a polynomial of degree n would be expressed as this guy here. Let me just try to be annotating. Would be expressed as this guy f of x, where n is an integer. It can be positive, it can be negative, but in this case, I'm sure n was positive. It doesn't matter the value of n, but what we should know is that the highest power of x is actually the degree of that particular polynomial. So then, if we have polynomials, let's say we express a polynomial f of x as the whole lot of that equation, where these an minus 1, a subscript n minus 2, up to n naught. These are coefficients of that particular polynomial. So if we are to say that certain polynomials are equal, then it means their coefficients are particularly equal, because these variables would cancel out at some point if we are to equate two polynomials. So then going to division of polynomials, when we are dividing polynomials, okay, any polynomial can just be expressed, let's say, as a factor of different polynomials of lower degree. So in this case, we have f of x being expressed in terms of p of x, q of x, and r of x. R of x in this case is the remainder polynomial. Then p of x is the divisor. And q of x is actually the quotient, the result of what we get when we divide the polynomial f of x by p of x. We would actually get q of x and the remainder r of x. So if we are to divide a polynomial f of x, say we have f of x, this particular f of x, well, if we are to divide it by p of x, what we would actually get is another polynomial of lower degree than n, plus a remainder polynomial. Sometimes this remainder polynomial may just be a constant. And let me just try to see if I can get a few examples. For examples, I think I'll just try to be solving the tutorial sheets. Is that okay? So, in dividing polynomials, we use some methods like long division and synthetic division, or we may actually just use factors, factorizing a polynomial and then dividing it through. So I'll just go to the tutorial sheet. When dividing polynomials, how do we divide polynomials? Say, okay, this particular one is asking us to use synthetic division. So let's use this, tackle certain questions from this guy. In dividing polynomials, make sure that you align all the coefficients that are needed. For example, if you have a polynomial of degree 4, then you need to have x variables, or you need to have 5 terms in that polynomial. If you have a polynomial of degree 3, then you need to have 4 terms in that polynomial. If you have a degree of polynomial n, then you need to have n plus 1 terms of that polynomial. So let us get this particular question. Was that a question? Or it's just a feedback? Please turn off your mic as you join. Thank you. Okay. So for this particular example, use dividing polynomials using long division. I'm going to pick out, I think, this example 5, where we have x to the negative x to the power 4 being divided by negative 2x squared plus x minus 3. So we have this polynomial of degree 4, which is the highest power of x. We're going to tackle this guy as our example using long division. Just like what we were doing a long time ago back then when we were in, was it grade 5 when we started long division? Let me just start sharing the whiteboard. So in this case, we are saying we are dividing x to the power 4 by negative 2x, negative 2x squared plus x minus 3. So using long division, basically, it's just doing the same things we were doing using this fail. So what we have here is negative x to the power 4. But what we know is that when we have a polynomial of degree n, it should have n plus 1 terms. For every polynomial of degree n, it needs to have n plus 1 term. So in this case, we would have, this would be a 0 here. It's just convenient that we put these zeros. This would be 0 x to the power 3, 0 x to the power 2, but trying to exclude those fellows. This is plus, not times, just in case somebody might get confused. This is not a multiplication sign, but an addition sign. So we need n plus 1 terms, which is going to be 5 terms. Just like that. Then in this guy, we have minus 2x squared plus x, and we have minus 3. So in dividing, we just look at this highest order, since the highest the degree of this divisor is 2 and the degree of this is 4. So we would definitely just divide throughout this. So we divide this into that. Negative 2x squared into negative negative x to the power 4. So this guy into this guy, how many times does this guy go into this guy? Definitely this guy goes into this guy, 0.5 x to the power 2. I hope you guys are following me. When you divide negative x to the power 4 divided by negative 2x to the power 2, what you get is actually 0.5x squared. Are we in agreement? I suppose we are. Then you multiply these guys. So when you multiply this, you'd have negative x to the power 4. This multiplied by that, you would have positive 0.5 x to the power 3. When you multiply this by that, you have 3 over 2, that's 1.5, right? negative 1.5 x squared plus 0 plus 0. Then we subtract at this point, this minus that, so that this guy gives us a 0, which is as good as not writing it. 0 minus 0.5 x to the power 3, so the remainder here would be 0.5 x to the power 3 plus 1.5 x, which is squared. These other guys will just be zeros. Then again, since we can divide, this is of higher degree than this, then we need to further divide. So when we divide again, negative 2x into this guy, which is 0.5x to the power 3 over negative 2x to the power 2. So what you'd actually get is plus 0.25 x. So when you multiply this, 0.25 times 0.25 times 2 gives us 0.5. This guy negative 0.5 x to the power 3. When you multiply 0.25 x times x, we would have positive 0.25 x squared. Then this guy, that's 1 over 4 times 3. Going into fraction here, I'm going to use fractions. This is going to be 3 over 4 x, which is 3 over 4 in decimal point 1, decimal notation. Then at this point again, we subtract this minus that. This is going to give us a 0, 0.5 or 1.5 minus 0.25. This is going to give us 1.5 minus 0.25. It should be 1.25, right?
Mm-hmm.
That is going to give us 1.25 x squared. 0 minus negative 3 over 4x. This is going to be positive 3 over 4x. Sorry, I'm mixing fractions and decimals, but that's not a big deal. Then again, this and this are of equal degrees. So we can just still divide this into that guy. Negative 2x squared plus x minus 3 going into 1.25 x squared plus 3 over 4x. So how many times does this go into there? When this goes into this guy, 1.25 over 2, that would be 1.25 over 2. Getting slow with this small math, right? 1.25 divided by negative 2. This guy into that guy into that guy. What do we get? We would actually get 0.6. This guy goes into that guy, 0. This guy into 12, that's 6. this guy into 5,
0.25.
that's 2, that guy, so it's 0.65. So at this point we have negative 0.625. The x's will cancel because this is x to the power 2 and this is x to the power 2, x into x to the power 2 into x to the power 2, that's 1. So now we multiply this guy and that guy. 2 times 0.25. Since this is negative and this is negative, so this guy is going to be positive. It's going to be 1.25 x squared plus, or rather minus, minus 0.625 x. Just try to clear this line. Then negative 0.625 times 3. That would give us 3 times 5, that's 15. 3 times 6, 2, that's 6, that would be a 7. 3 times 6, that's 18. So this guy give us plus 1.875. I know you guys don't use calculators, but do not be tempted to use a calculator at any point. Just work out the math. If possible, have somewhere else to work the math from. Then at this point, we add, this would give us a 0. Let me see, what is 0.625 in fractional form? Or what is actually 3 over 4 in fraction? This is actually 0. That would be a 30. How many 4s do we have in a 30?
7.
We would have, it's actually going to be 7. 7 times 4, that's 28. That would be a 5 there, 0.75. So this is 0.75 minus 0.625. I just have my 0.750 minus 0.625. This guy here give us a 5. This guy give us a 2. This guy a 1. This is 0. So this is going to be positive 0.125 x plus 1.875. At this point, we cannot divide any further because x divided by x squared is going to give us x to the power -1. So at this point, we have divided. Then if we just go back to the notes I was sharing, just a moment, let me just try to go back to the notes I was sharing. Just switch the share. Since we have divided by, say, p. So in that case, our p, which is the divisor, was negative 2x squared plus x minus 3. So we need to express our f of x in this form, so that the remainder is shown together with the divisor. Where is my whiteboard? I hope I haven't lost any boards there. Okay, the board still exists. So in this case, x, negative x to, no, let me just move on to the next board. Negative x to the power 4 over negative 2x squared plus x minus 3. Is actually equals to, so we'd have the quotient, our quotient, which was this is the quotient 1 over 2x plus 1 over 2x squared plus 1 over 4x x plus whatever this is in fractional form, but let's just use the same, which is 0.5 x squared plus 0.25 x, was it plus or minus at this point? Minus 0.625. This is going to be plus. What was our remainder? Our remainder was 0.125x plus 1.875. Remainder was 0.125x plus 1.875. The whole lot of this over negative 2x squared plus x minus 3. So this would be our expression after dividing this by that. And then using long division, this would be the process here. Whatever we've done here is the process. So this covers our example for using long division in dividing polynomials. Do we have any questions so far? Okay, I'll take that there are no questions. Then using synthetic division, I'll pick on another example from the tutor sheet so that we cover the tutor sheet as our example. Using synthetic division, this is where you need a factor. You'd be given, so you have this, this polynomial being divided by here. So in this case, this is the factor of that particular polynomial. When you divide this into that, it gets certain other values. Let's just try to get an example. So question 5 is particularly asking us to use synthetic division. It says use synthetic division to divide the polynomials and write the function in the form px is equals to x minus k multiplied by q plus r, where q is the quotient and r is the remainder. Given the dividend and the divisor as follows. So for this particular one, let me use which one as my example? Let me use question 3 as my example. So question 3 as my example, it says x to the power 3 plus x squared minus 21x minus 10. Then the divisor is 2x minus 1. So using synthetic division, we need to get the value of x with which this polynomial is divisible. Your mic here, Mr. Mbebe, please always turn off your mic as you join. Let's go into solving this particular one. So we had polynomial as 6x to the power 3 plus x squared minus 21x minus 10. This was being divided by 2x minus 1. So having this particular factor, we need to find the value of x. We equate these to 0 so that we find the particular value of x, which is -1 is equals to 0. So that x in this case would be equals to 1 over 2. So 1 over 2 is our factor for this polynomial. Then using synthetic division, all we need are just coefficients in this case. The coefficient of x to the power 3, the coefficient of x to the power 2, the coefficient of x to the power 1, and the coefficient of x to the power 0. Then say 0 there. Just drop down this. It's as good as dropping down this. Then our factor in this case is 1 over 2. So here you multiply this, and whatever is here you multiply, and these that are in here you add. So now in this case we're going to multiply 1 over 2 times 6. That would give us a 3. In this case we add again here this by that. This would be a 4. This by that. That should be a 2. We add this. What we get is actually 19. Negative 19. This by that. That is 19. Negative 19 over 2. When we add this, we would have negative 20 minus 19 over 2, which is going to be negative. Oh, I only have 10 minutes. Negative 39 over 2. So this is actually what is the remainder in this case, because this would be the coefficient of x to the power, the lower degree polynomial, which is x to the power 2. This would be the coefficient of x, and this would be the coefficient of x to the power 0, which is just a constant, and this is equals to r, the remainder. And from the question, we are told to express this as x minus k, where k is this guy, times, let me just check, times qx plus r, where qx is the quotient and r is the remainder. So in this case, our polynomial p of x is going to be expressed as this guy. You can just take it the way it is. If you want, you can just use the same x minus 1, 2x minus 1 rather, 6x squared plus 4x minus 19 minus 39 over 2. So this is actually px. When we multiply this and add this other guy, what we'd actually get is this particular polynomial. So in using synthetic division, the procedure is that get the coefficient of that particular polynomial, align them props, get the factor, find the value of x of whatever divisor you have. So in this case, just equate this particular factor to 0 and get the value of x, which is in this case what they were saying as k. Then drop down the first coefficient, the coefficient of the highest power of x, drop it down, multiply it by a factor, add it to the lower coefficient of the coefficient of x of the lower power than the highest. Just follow this procedure by adding this and multiplying it with what you get. So when you add, you multiply the sum by the factor, then add it to the next available coefficient, until you reach this point. Then what you'd get, your quotient is actually 1 degree lower than the particular polynomial you were what? Dividing. Is that clear? Or maybe we need another example.
It's clear.
Oh, thank you. Everyone else, is it clear? Online learning is quite difficult. So we need to be responding so that I know we are moving at the same pace. No one has to be left behind.
It's clear.
Okay, thank you, Mr. Mbewe. I think we have 3 people confirming that it is clear. Let's see if we can do another example. Where are those notes I am sharing? Okay, I have about 5 minutes remaining. So if the meeting ends, you can just quickly join in using the same link, okay? So we have covered these parts. Long division, I've shown you an example. Synthetic division, I've also shown you an example. Then what about factorizing these polynomials? How do we factorize a polynomial? Say we have this particular polynomial that I gave as a definition. If you want to factorize this polynomial, first things first, these are the points that you need to follow keenly. Just follow these religiously and you'd find it that it's easier to factorize a polynomial of n degree. So first of all, get factors of these numbers that can go into this particular constant without leaving a remainder. Then also get factors of this particular coefficient, the coefficient of the highest order. Then get D, which is going to be a series of values, by dividing every other factor of this with the corresponding factor of every other factor of A naught with the corresponding factor of AN. Explaining just this with words won't be enough. Let's see if we can just get an example to factorize completely. Say we have, let's see if we can do this in the next 4 minutes. If it's not clear in the next meeting when this ends, please feel free to ask. So we have this particular polynomial, says x to the power 3 minus 12x minus 16. They're telling us to factorize this completely. Just quickly try to switch to the whiteboard. So we have p of x is equals to x to the power 3 minus 12x minus 16. So first thing first, let us get the factors of A naught. So A naught in this case is equals to negative 16. So its factors would include 1, 2, 4, 8, and what? 16. Then this other guy is just AN, which is A2. Is actually the factors of A2, the coefficient of A2, or the coefficient of x to the power 2 rather, which is just 1. What are these factors? Then actually these should be plus or minus, plus or minus, plus or minus. The factors of 1 is actually just plus or minus what? 1. Then we start dividing this. So when we divide this, what we are actually trying to get is we're trying to get a number that we can replace into this polynomial and get a 0 in the end. We need to find actually It's called a root in this case. This is a particular way of finding that particular zero of this polynomial. So if we divide 1 by 1, let's see if we try 1. When you divide a by 1, this 1 by 1, let's say if we have a 1, what is p of 1? P of 1 is, I think we're just going to solve it mentally. This is negative 12 minus 16. This is not equals to 0. 1 is not a factor. Even if we try negative 1, it can't work. Let's try 2. What is P of 2? This is actually trial and error. So you need to be applying those intelligent guesses. If you look at this is 16, this is 12, and this is x to the power 2. So the easiest you get is actually a factor has to be has to be 2 or minus 2. So if we try this one out, and the meeting is actually ending, and I will lose this board. So I advise we just end this meeting and rejoin in as soon as possible. Let me just end this meeting so that we can join into the next.